All right. Hello, welcome. This is my day 3 stream of working on my game engine Gunship. Last couple of streams, I've been working on my asynchronous code management thing. I don't really know what to call it. That's my system for doing asynchronous multi-threaded operations throughout the game engine. Last stream, I got some basic resource loading working. I'm able to load a mesh off of disk and load a material off of disk, load them in parallel and get them both of their data associated with the renderer, and then return that information asynchronously. The next step in my little list of to-dos up here is to create an entity or create the mesh in the scene so that it can be rendered, and create a camera with which to render it. And in the last couple days since I streamed, I've been thinking about what exactly I want that API to look like. So what I've done here is I've mocked up a really simple example of an API for doing just that. This API is based off the idea of doing an entity component system, where for each of the things in the scene I would create an entity, and then I'd associate various components with it, like a transform component, which gives it a position in world space and a spot in the scene graph, a node in the scene graph. A mesh renderer would allow me to give it a mesh that would be rendered by any associated cameras. And a camera component would be required to render to a viewport on the screen. Now, at the very least, transform, mesh render, camera are all things that I'm going to need one way or the other. I need a way of giving stuff a position in world space. I need a way of specifying what meshes are being rendered. I need a camera for specifying how, doing the camera, doing all the stuff associated with rendering to the screen. The part that I am not so sure about, and I'm actually planning to move away from, is entity. I've always attempted to go with an entity component system. My experience with game development is really heavily influenced by Unity, because pretty much from the time that I started learning game development in college to today, I've been working with Unity nonstop. And while I have a lot of problems with Unity, it is overall a pretty solid system to work with, and especially the design of the gameplay API, the component system that they use, where you create game objects, you associate components with game objects, and you can swap those out on the fly, and you can get components associated with other game objects, and you can modify them, and you can attach them and remove them and do all sorts of things. It creates for a really dynamic game state. It's really easy as a programmer to change the shape of objects in the scene very quickly, and that makes stuff like prototyping and testing out new things in your game development possible. It makes entire new patterns of just like ways to achieve certain results possible. And so that's, in my previous attempts at building a gameplay API, that's what I've gone for. I've attempted to create a similar entity component system, and I've tried it in a couple of different ways without much success, to the point where I've written a blog post on my blog about the problems that I run into when I attempt to implement it in Rust. And the problems don't really come down to a technical level in terms of just is it possible to implement an ECS in Rust, so much as it comes down to ergonomics. If you take a look at this API that I've written here, you'll notice that when I create components, I'm not explicitly referencing any global engine state. When I create an entity, this is returning some chunk of data, and I can actually show you what entity looks like. Entity is just an integer. It's an integer identifier. well, with a little bit of, ownership semantics wrapped around it. So a little bit of type safety added to it. And when I create a new one, in terms of creating the data, that's very easy to do. But internally, the engine needs to be doing some kind of tracking of those entities. It needs to either track which entities are alive or which entities have been destroyed, so that if you try to do anything with them, it can appropriately tell you that you're doing something wrong, or that it can recycle entity IDs, because U32 gives you 4.2 billion unique values, and I never anticipate there being more than 4.2 billion objects alive in the scene at any given time. However, over the lifetime of a long-running game, you might be recycling enough objects, creating and destroying objects, that eventually you'll go over 4.2 billion. And so we need some kind of way to recycle IDs in this case. And so, I've got Entity Manager, which does that. It keeps track of destroyed entities, recycled entity IDs, keeps track of the live entities. And so when I create a new entity, I never make it explicit that I'm interacting with that entity manager that's owned by the engine. That's happening in the background. And what I can actually see here in entity new, it gets the singleton of the engine, gets at the scene, and it goes to the scene. The scene is what owns this entity manager, and then it asks the scene to create a new entity. So what this API is really doing is it's really accessing a singleton in the background. And the same goes for transform, mesh renderer, and camera. And that's all well and good. So, this requires some synchronization in the background. It requires that we get at the singleton for the current scene for the engine. It requires that we, in a multi-threaded context, we do some synchronization to make sure that we don't do bad, have like data races when we're accessing the data, but it's easy enough to get around. It gets more complicated though as we get into more realistic game code examples. So let's take an example. Let's say that we are doing some stuff, and then somewhere down the line we do something like let other transform equal transform get mesh entity. Let's say we do this. So now we've got one mesh entity. Up here we've created a transform for it. And then down here we have retrieved the transform for the same entity. This is potentially problematic. But let's take a look at it this way. Mesh transform dot translate other transform dot translate. These two objects are effectively referencing the same data, and they are both able to mutate that data. This is verboten in Rust's eyes. Shared mutability is the root of all evil, and one of Rust's major goals is to allow you to avoid that issue at compile time, not having to use runtime checks to ensure that you never have shared mutability. Effectively, what we've done is by using the game engine, I've introduced shared mutability, and I've kind of done it accidentally. Now, there are ways to get around this problem. We can make it so that translate doesn't mutate. It does something so that it doesn't mutate mesh transform, so it's safe to do this for multiple places, for multiple threads at a time. The current implementation that I have, the last one that I tried was message passing. Anything that could mutate any component sends a message that gets queued up, and then they get processed all sequentially, and all the mutations are applied at once when we know that there are no borrows out on that component. It's something. Maybe that would work in the long run, maybe not. Problem again came down to ergonomics. It wasn't clear. You tell it to translate, and then just tell it to translate, and then do mesh transform get pose, and it's not what you would have expected to be after this. Like the translation doesn't get applied immediately, or something. It became a hazard, and it was also a ton of boilerplate code to write inside the engine. Anytime you wanted to add a new component, there was a ton of boilerplate to be added. Not really ideal. Ultimately, what this problem comes down to is by having this entity around that is effectively an identifier that can be used to get any component, this will always be possible. This entity logically has ownership over each of its components, but in practice has no ownership semantics. If we take a look at the way that I've built entity so far, it's actually clone and copy. And the logic there was, like, entity should just be an ID. It should be cheap and easy to pass an entity around to allow one piece of game state data to reference another piece of game state data without actually having to have a borrow out on that other data. So that will allow me to pass entities around across threads, across components, and then those can just sit there without any ownership semantics. And then when it comes time to actually get at the data that they're referencing, you have to do you have to go through one of these getter methods to get the component. The other thing we could do is to avoid it is, like, this getter method could be doing some kind of checks. So this could say, oh, if there's already a borrow out on the mesh transform, panic. Basically say, oh, you got a bug, you shouldn't have been doing that. Or in a multi-threaded context, do a mutex lock, block the thread until another component gets there. In the case of the mutex lock, that works, but it's a performance hazard. Having to block a thread until the other one gives up the resource that it's looking for is going to basically undo all the advantages we get from having a multi-threaded engine in the case where there's high contention for a single resource. And in the former case where, we just panic if there's another borrow out on the component that we're trying to access. In the multi-threaded case, that's already a hazard because there's no way to predict if another thread has access to a component. And in the single-threaded case, it is, again, a usability hazard. That was the first thing that I implemented. I think I internally had rest cells around every component. And if you tried to get a component that was already borrowed, the ref cell panics. And that quickly became a pain to use because, if I wrote a helper method that attempted to create a new component or access a component and mutate it, that helper method had to retrieve the component, but didn't know if somewhere up the call stack that same component had already been retrieved. And it may not even be consistent. The stars may only align occasionally where it's borrowed in both places, and I have to make sure that it doesn't come to be that is not borrowed. And then this is, all of these things are avoidable. You can avoid them through writing, like, the practices that you use when you write your gameplay code. You could write the helper method to take a reference to the component rather than trying to retrieve the component. That works in some cases, some of the time, but ultimately it comes down to the gameplay code writer, the game developer, having to work around the limitations of the game engine. They have to butt against problems at runtime rather than having the compiler tell them what they're doing wrong. And really, if there's really something that Rust's about, isn't it having the compiler tell you why you're wrong? And so that's what I want. I want an API where as many errors as possible are going to be caught at compile time. And while I still don't really know what the ideal way to do that would be, what's going to be that best, most rusty API for game development, I think I would like to take a step away from entities. I don't necessarily think they're bad. My suspicion is I will eventually return to them once I have things figured out, or more likely somebody else within the Rust community has things more figured out, and I'll adopt their solution. But for now, I'd like to go with a maybe simpler solution where we get rid of the entities and we just have components. Although components will no longer be components, they will just be resources? I don't really know what I'm going to call them. Ref mesh. I'll do ref mesh transform. So the idea now is that the components that I previously had, which were not owned by the entity, but were owned by the game engine, and the user could borrow them doing those get methods. They're now handles. You create them with new. They have destructors, or they have a drop implementation, and their drop implementation, once run, tells the engine, okay, you can clean up this data is no longer in use. So each of these, this transform object, this mesh render object, this camera object, all have ownership semantics. And their ownership semantics say, I am the one true owner of that data, even though that data is really, like the real data is internal to the game engine. But these confer ownership. Owning this object means that you are the exclusive, the one place in game code that has access to that data. And it means that if you want to lend out a mutable reference to that data, it's safe to mutate through that reference. If you want to lend out multiple shared references, it's safe to share those references. The game engine does technically have access to that data under the hood, but the game engine is going to be designed to make sure that it's not ever mutating that data in a way that's going to invalidate these handles or lead to any memory unsafety. And I think, while that still leaves a lot of questions unanswered about what it's going to look like when you try to develop a game, I think this is a very simplistic design, and I think it will leave a lot of room for me to experiment with building other gameplay designs on top of it. And so I think that's the direction that I'd like to go in for now. I'm going to start with just making this simple example work, which I think is going to be a nightmare that'll probably take me multiple days because I have to refactor huge chunks of my game engine. And then on top of getting rid of the idea of entities within the game engine, I'm also going to have to make everything thread safe, everything that was not previously thread safe. So I've got quite a bit of work cut out for me now. I've kind of dug my own grave in some respects. So I'm going to start with this, and start with just compiling things. Oh, and so this is where we're going to start, and then we'll go from there. Last thing that I also did while I was in between streams, previously I had made a function to access the renderer that's owned by the engine using a similar method to the once type within the standard library, as well as the thread local storage type within the standard library, where instead of having a getter that allows you to just return a reference to the data, this static data that's not really static, and having like questionable lifetimes associated with it, I've instead opted to do a version where you pass in a closure, or really just a function that takes a reference to that data and then can return any old value. And I've done the same for scene. Engine is still a singleton for the time being. It'll probably always be a singleton. But now previously to access the scene, it was pub function scene and then returned a static reference to the scene, which was bad because that scene wasn't actually static. And there's potentially a bunch of ways to invalidate that reference. So instead what we've got now is we take a closure, there is a mutex around the scene. If we go up to right here, there's not a mutex around the scene. Now there's a mutex around the scene. So we lock the mutex, we pass a mutable reference to the scene data into the closure, and that's that. This has now broken what little bit of code was already referencing the scene, because I was not previously doing any of that. So let's do cargo run example experiment and start with that, and then we'll gradually move our way into dealing with getting rid of the concept of entities within the engine. Boy, oh boy. This function takes one parameter but zero parameters supplied. Mesh.art, component/mesh. So I'm replacing mesh with mesh renderer because I now have a resource called mesh, and I think I previously had a resource called mesh as well, but actually the resource will probably wind up being called mesh ID or mesh handle or something, but calling it mesh is a bad idea. But also calling this component mesh is a bad idea as well, because this is really more of a mesh renderer or a mesh filter. If I want to make analogies to Unity, which is kind of the only point of reference that I have, so I kind of have to make references to Unity. So this is going to get renamed, but in the meantime, let's just focus on where we are trying to access the scene. 24 engine scene.manager for mesh send message. Ooh, and that's that junky message passing implementation that I was talking about. Mesh set material set material. So we are going to, we probably don't care about any of this stuff for now. In fact, it may well be safe to say that we can delete all of this. I'm going to not do that just yet because I don't know how much of this stuff is going to remain relevant. But yeah, we can do a nice juicy unimplemented right there. Just a nice fat unimplemented. I guess that can stay there while this is defined this way. Entity is going to go away though, so who knows what the heck's going to happen. Engine 81, scene cannot be dereferenced. Type scene cannot be dereferenced. What the heck are you talking about? That should be a mutex guard, right? Instance, scene, lock, unspect. Unspect. Do I have one too many stars? Hello? Okay. Guess it just kind of froze up for a second. We back up to the top. Engine 151 scene dot input dot clear. Okay, cool. Cool. Just super cool. Just my favorite. Let's take a look. All the ways that we attempted to access scene that are no longer valid because the scene is now wrapped in a mutex. Plenty of ways. Just many ways. All right. This brings up the question, because I was thinking about this when I was writing my scene getter. I'm wrapping the scene in a mutex. However, scene itself is also a wrapper around a bunch of data. And when I wrap the scene in a mutex, where's my scene? When I wrap the scene in a mutex, it forces me to synchronize access across all of these various things. So I've got an entity manager, I've got a manager map, which is also just another example of things being potentially troublesome. I've got the input manager, I've potentially got an audio manager, including a nice big old fix me on top of it. each of those things are going to potentially be safe to access independently in parallel. So if I synchronize access to the entire scene, that's not necessarily ideal, because like an access to the entity manager and access to input can't happen in parallel. And there's no real logical reason why that shouldn't be able to happen. So the question becomes, do I not, instead of wrapping scene in a mutex, I wrap these things individually in a mutex? And this kind of becomes a trick question, because I think the answer is we get rid of scene entirely. So the idea behind scene, when I originally created it, was that scene would actually be passed into all of the gameplay code. So to go to our experiment example, setup scene would be done like this, ref mute scene, or even, I think it was even just ref scene. And then when it comes time to create transform, we actually do like scene, new component, transform, that sort of janky junk. And I said I did a number of different attempts at this. This is the version where I make all the lifetimes explicit by passing in a reference to game state into gameplay code. Like the engine invokes gameplay code by passing a reference into it. And that's how you make sure that gameplay code doesn't violate any of the lifetimes of any of the data. But that in turn had a bunch of problems, such as borrowing from the scene once borrowed everything. It was a very coarse-grained borrow. So if I create a component, I now have a borrow out on the scene, but if I wanted to access input, I could no longer do it because the scene also owned it. Even though those are completely disjoint, it should be safe to mutate or access input in any way, but I could no longer do it because the scene has access to it. And so that's how I wound up getting to the ref cell version. I was like, oh, well, I'll just wrap everything inside scene with ref cells, and I had ref cells inside of ref cells so that I could borrow stuff while I borrow stuff. And the end result was lots of panics, lots of failures at runtime. Ultimately, not very happy with that solution, which is why I'm now going in another different direction. So as a result, scene doesn't have a ton of purpose. There are some limited cases where it would be useful. For example, if I wanted to completely reset the state of the current of the world in the game, just like kind of everything all at once, it would be possible in theory to, if scene had access to all of the entities and all of the component state data, wiping away the scene and creating a new one to completely reset game state would achieve the desired effect. However, there are probably better ways of going about that. Or at least I could, even if there was no explicit scene, I could still have a function on engine that's like engine wipe away game state that could just, clear the entity manager and clear the component managers. Good enough. So I feel like I'm going to regret this, but I might want to just completely gut the scene. Considering that I'm getting rid of the idea of entities and components and potentially component managers, all of that's going to probably just kind of go away. Yeah. We'll have to see what that's going to do. I'm going to take a quick break to get myself some more tea and run to the bathroom, and then I will be back. Just a moment. Alright, I'm back. I've got some more tasty tea, and I've got about half an hour left to get started on this work. So, or not really get started, but continue on this work. Ah, shit, did I decide that I was going to kill Scene? I think I'm going to kill Scene. Now, what's engine going to look like without a Scene? I'm going to just have to either comment out or delete a ton of code. So I'm super excited about that. Are you super excited about that? I'm super excited about that. Audio update, alarm update, collision update. That's all just going to get killed because this is just going to have to... That's just not a thing that's going to exist. Systems, debug systems, all dead. Debug draw, I guess, can stay there. Close, debug pause. I love debug pause. So we're not getting rid of debug pause. Render is going to stay there. It's in a mutex. Eventually we want it to not be in a mutex. Window, I hope nobody tries to access the window. Let's just get rid of that. Resource manager. Resource manager is also not a real thing currently, so that is just going to have to go away. And that leaves us with pretty much nothing. Just kind of fuck all, really. Which is amazing. Spent like a year on this engine, and I'm now just gutting it and leaving myself with nothing. Yeah, get that sweet tea brewing action. Oh god, I'm scared to find out what all those compilers are going to be. On the other hand, I can actually make this a little bit easier on myself by not trying to compile components that I'm not using currently. So I've got this little component module. Oopsie, wrong one. And by little, I mean completely impractically large component module. And here's what I'm going to do. In my component module, I've got all of these mods, and I'm just going to get rid of all the ones that I'm not using. Boop. And then I'm also just going to comment out all of this because I don't want it anymore. And we got transform camera, and then fuck it, I'll leave mesh in there. Transform camera mesh. That's all we're starting with. Starting nice and simple, as easy as can be. And that's going to probably give me enough hassle to just eat up a ton of my time anyway. So, yeah, look at that. Look at that error spew. Let's see. Can you see where this is? Oh, God, this... Okay. Default manager, component manager, mesh manager, transform manager, default manager. We need lights. We need light manager. Where do we need lights? Oh, use statements. Use statements. I'm not going to have to rewrite all of my rendering. I forgot about that. I have the whole problem of I rewrote my renderer, and then I didn't bother updating the engine to use the updated renderer. I just kind of commented everything out because I didn't want to bother rewriting the engine to the component-based engine to use the renderer, since I knew I was probably going to be getting rid of components. So I'm wondering how much of this engine is even worth saving when a good chunk of this engine is pretty much trash. That's just the trashiest of trash. I'm thinking. I'm wondering if I shouldn't just create a top level. So I got this async module. I'm wondering if I shouldn't just make this async module a new top level game engine. I'm wondering if I shouldn't just fork my entire engine and make a new one from scratch. Yeah, so here's what I'm thinking. New file, engine.rs. Fucking starting over. We're basically building in this async module. I'm going to start, I'm just going to kill everything as quickly as I can. I'm going to start building a new engine. And at the top here, the top of Gunship, what I'm going to do is this all deleted. This all deleted. And I will slowly start moving things in as I get to the point where that's okay. Let's take a look what we got in here. We got new async resources that'll go in here. This async is going to get renamed to resource. Should be resource or resources. Standard library names their stuff collections. Right, so let's take a look. Let's do std. Let's take a look at what the submodules of std are. You've got collections. So anything else that's comparable. Intrinsics. There's like result. There's process, which is for working with processes. So would the module be resource for working with resources, or would it be resources like collection is collections? These are really the important questions. These are the questions that I need to be spending as much time as possible on, because everything else just pales in comparison. I'm gonna leave it resource for now, even though I'm probably gonna, every time I try to use it, I'm probably gonna assume it's resources with the S at the end of the S. Okay, so what I can probably do is in Git, am I looking at the wrong repository? I am looking at the wrong repository. Experiment can stay how it is. Async engine is new. Async resource got moved from resource async. Hopefully it's smart enough to detect that, which I don't think it was. These changes are going to have to be kept, but these other changes to engine are perhaps not. So the other problem is I already made changes to engine on this branch, so I don't know. I guess we'll not worry about those. Discard changes to ECS because those are going away. Changes to scene are also going away. Component going away. Component mesh going away because those are simply no longer going to be, they're not even going to be compiled anymore. Yeah. So that is now what we are working on. Let me just double check Gunship. Macros and async are the only thing that we care about. An experiment is using use Gunship, extern create Gunship, and then we got extern create Gunship async, whatever. That's not necessarily what we want, but no, I never. Should probably have a prelude. You know, just like in Unity when you do using Unity engine, it kind of just pulls in everything. You don't really have to use a ton of the sub namespaces. I'm pretty sure they just use the sub namespaces for stuff that was added in later versions that they probably don't want to add to the Unity engine namespace for backwards compatibility reasons, forwards compatibility reasons. Same thing here. I can do, you know, prelude. And in here I can do new file, prelude.rs, and mod. So we got mod scheduler, and all this stuff that's in the module should probably get moved into scheduler. And then we've got mod engine, mod resource mod prelude. And then we got to sort these, QRS, P. Got to sort those so that they are super legit, too to quit. Let's take all of this janky junk, move it into scheduler, and we're gonna see how many errors that I run into. So init's gonna talk to scheduler, scheduler. That's going away. In fact, all the times I reference scheduler. So we got init, we got start workers, which calls wait for work. Create fiber calls something. Fiber new, finish, calls run, calls finish, start. Await calls wait for. Coolio. I'm gonna have to, basically anything that involves working with fibers is gonna be unsafe for the foreseeable future until I can prove that they're not, which I absolutely cannot prove that they're unsafe. I'm pretty sure, not gonna get into it now, but let's just say my fibers implementation is bullshit. Just complete bullshit right now. This might actually, wait for work might actually be safe currently, but we're going to allow all these to be unsafe, and then the public safe API is going to be the stuff that I just copied from the root level. Init is also redundant because with does everything, it just gets called whenever it needs to be called. Let's see, I think the reason why I have to have a init here to make sure that we do our initialization is because it's possible to that initialization has to happen before we ever call fiber.makeActive. Make active, and that is called by wait for work, and I believe it is possible that we will call wait for work before we ever call scheduler with. Specifically, if we try to call wait for work before we try to call scheduler with, and wait for work specifically does not use scheduler with, it accesses the mutex on its own so that it can do this convar magic, we will run into problems. So I'm going to leave that there for now, this init, but I mean, I would like to eventually get rid of it, allow the scheduler to either be completely lazy on its own or something else. Because I think the idea is this whole scheduler dealio, this whole diddly bopper, which is basically how I'm doing my asynchronous, fiber-based coroutine whatever operations. The idea is that this can probably be split into its own crate, and it can actually be something that I can publish to crates.io because it is got some pretty reasonable functionality on its own that I think other people would get use out of. But that's something I'll worry about later. For now, let's take a look at what we're doing in our new asynchronous engine. We got engine, we got prelude, we got resource, we got scheduler. Engine, we're going to have, I don't know what the fuck we're going to have in engine. Probably pub struct engine builder is what we're going to have. Derive, debug, pub struct engine builder. tasty tea. And this can pretty closely mimic what I was doing in the previous engine. We just collapse all this and take a look at what's going on in Engine Builder. So we got struct engine builder and impl engine builder. Engine builder requires, systems, debug systems, managers, max workers. However, I don't really care about, half of those things. Actually, I'm pretty sure at this point, the only thing I care about is the workers. So we're going to go into our new shitty engine. We're going to paste all of that in. We're just going to slap on that derive debug. We're going to do, none of these things exist currently. I am not currently supporting any way of doing user-defined components or user-defined gameplay code, because my suspicion is that's simply going to be done from external to the engine. And I already know reasons why that's going to cause problems, but I'm going to try to address those issues later on down the line. So we'll see what I come up with. So engine builder new, max workers 1. Get rid of all of this janky junk. We're going to do builder.build, which I don't care. Max workers is the only one we really care about. We're going to get rid of register component, get rid of register manager, get rid of register system, and register debug system. That whole debug system thing that I had set up originally was pretty cool. You could do a debug pause on the engine, hitting like F11 or something. And what that would do is that would pause all normal gameplay code, stuff that ran normally, and it would instead swap out a set of alternate update functions, alternate behaviors that could be used for debug functionality. So say you got like your stuff moving around like normal, you're shooting your gun, shooting bullets out, particles are going off, explosions, even though I didn't have any particles implemented. You could debug pause, all that stuff would freeze, and then you could enable like a debug camera. So you could do like fly around, take a look at what the world was doing, and everything would stop. So if you were, say, having performance issues because there's too much stuff being rendered or whatnot, or too many things getting processed, you could debug pause. Performance would like return to normal because now nothing was updating. Basically, all that was happening was rendering. And it would still render every frame, and it would still run the game loop. So the window wouldn't lock up. It was really cool. I was proud of it, and then it also was kind of useless because the engine that it was built on top of is kind of useless. So we're going to start with, this is basically garbage. This is trash. Building the window is less so trash. I'm going to, for stuff like this, I'm tempted to move it into a helper function, but it's a helper function that's going to be called from literally one place, so I'm not so worried about it. Barrier.clone.wait, and then we're going to do mem drop barrier because we are done with it. And we're going to let that just run off the edge so that our barrier deallocates. Renderer, we will still build because our renderer is polygon. That is defined within this library, so I can still use that in my async context. Debug draw I will have to kill for the time being because debug draw is not ready to be thread safe. No such thing as a resource manager, no audio source. I'm going to just have to completely revisit my audio library down the line because it sucks and I need it to suck less. Basically, the only thing that's going to go into our engine currently is our window. which I can live with, is I'm probably gonna also, or my window and my renderer. Renderer new, render builder new, window. There we go. That's another weird thing, is like the renderer should probably have a lifetime associated with the window to make sure that you don't, say, destroy the window before you are done with the render. Don't like start trying to render to a window that no longer exists. I think in practice it kind of doesn't matter. It's not really. The hair in my mouth. Ugh. I think it's something I'm not really concerned about right now. So what we're going to do is we're going to do a window. I'm going to start with just renderer. Renderer. We're going to start by not mutexing it. But I know already that that's going to be a troublemaker. It's going to cause me problems. Our prelude, we want to pub use async engine builder. So that's our prelude. Probably all that we care about is a prelude for now, because everything else is the only other top level things. So we've got my engine builder that I do from the top, and got resources. So it's actually going to flip around. Resource async is going to turn into resource. So we're going to do engine Gunship async, perhaps. Resource load mesh, resource load material. So that's going to be that. And then the other one, so we got transform, mesh render. I still got to figure out what those are going to be though. So let's do. I'm going to make the engine itself pub, I guess. Pub struct engine. Window render. It's going to have to be a box renderer. Maybe we'll make it an owned renderer. Whatever. Because owned renderer is just going to be a type alias for box renderer. So who cares? Let's make sure we can debug this. Coolio. So that kind of works enough on its own. Next thing that's going to fail on me is resource. Let's take a look at the way that we load a mesh. We'll see that we try to talk to the renderer when we load our mesh. Now would be a good time to rethink this, perhaps. So this kind of the problem that I have when I started writing this in the old version is this requires a mutex lock. Like this renderer method locks the mutex for the duration of this callback. Now, this is relatively simple. However, it's not necessarily ideal. I might be trying to load resources across multiple threads. I might be trying to do things. The more synchronization that we do in that respect, the more potential, the more performance that we're leaving on the table. So I think there is a smarter way of going about this. And I think that way is to do the magic of MPSC. The one channel that actually, does Rust have a different idea, a specification of what a channel is? No, channel is this multiple producer single consumer queue. I was talking to a friend about this yesterday. I was telling him about the channel primitives that we have, and in my head I was like, oh shit, am I explaining it wrong? giving him the wrong definition or the wrong explanation for what a channel is. It looks like I'm not. I told him that it was this multiple producer, single consumer queue, and that there are other ones like multiple producer, multiple consumer, single producer, multiple consumer, that sort of thing. But the important part is the channel is what you use to send data across threads, and that's what we're going to be doing here. So my idea is, rather than having, when we load resources, rather than locking a mutex and getting exclusive access to the render at a single time, what we will be doing instead is we are going to, when the resources load, we're going to basically queue them up and send them to the engine through this multiple producer, single consumer queue. And then the engine will process any pending resource loads before rendering. And that should work out pretty well, because when we load resources, and any render-specific resources like a mesh or a material, those aren't needed by anything other than the gameplay code until it's time to render. And so as long as we have some way of returning a result to the gameplay code once the loading and the processing is done, we should be good to go. That does bring up a little bit of a conundrum. We have the issue of, so let's take a look at this case. Let's take a look at let mesh equals await load mesh foo.da. What does this return? What is our type? And when does this return? In the case of the mutex version, this is actually returning the mesh ID that is provided by Polygon directly. If we take a look at Polygon, lib Polygon source lib, we take a look at the renderer trait, we take a look at what register mesh does, is it takes a reference to some mesh data, it spits out a GPU mesh. And GPU mesh is just a unique identifier. It's a wrapper around a usize, similar to the way that entity was. And that is what we were returning from, I think I lost my resource code. That is what we're returning from load mesh. And importantly, we weren't returning that value until after our mesh data had been synchronized and sent to the GPU. Which means if a failure happened at any point, I believe this can return an error of some kind. Let's take a look again at what that renderer trait specifies. Register mesh, oh, no, it specifies it as infallible, but I'm guessing that will not always be the case. This will probably be able to fail at some point. So once this is assuming this is returning a result, this operation may fail. So let's say that we do, instead of doing this, we do let's say that we have a resource manager dot queue mesh load mesh or something. And then this will, prior to rendering, do this call to renderer.register mesh, and we'll make sure that it works. We now have two pending questions. One, what are we returning here? This is now not obvious. Two, what happens if this fails? So let's say I load my mesh, I process all the mesh data, I queue this up, and then I return some value to gameplay code. Let's say we just make up an engine internal identifier, similar to GPU mesh, but an identifier that's internal to the engine I can create without waiting for the mesh to be sent to the GPU. let's say I return this value. So let's say I just do like let ID equals resource manager, and I return ID. So now we have something to return, but what happens if, we get to the end of the frame, or it comes time to start rendering, we begin to process this and this fails. The call that this eventually does to register mesh returns an error because the mesh is malformed, or it requires some feature that the rendering backend doesn't support. There are ways that we can handle this. I could handle this by printing a warning and simply not that mesh just doesn't render, or it renders maybe like a debug mesh, or maybe just renders like a sprite with a big old question mark or an X on it or something. We could panic, shut down the engine, be like, you're trying to run with bad data. We're just not going to let that happen. That could even be an option, like a configuration option to the user. They could decide whether or not they want to shut down on bad mesh data, or if they want to allow it to keep running. Probably in release mode, we'll shut down on bad mesh data because that is a buggy bug. Or maybe not. Maybe we want to fail soft in release instead of failing hard. These are all design choices that I think will not really be. You kind of want to decide when you get there. I think my solution will be, for the time being, basically just print out a warning and then roll over it. Stuff like a resource being missing. Actually, no, I want to go the other way around. If resources fail to get created, I'm going to just panic, hard kill the engine. Well, that's my general philosophy of handling bugs, and I think that's kind of Rust's general philosophy for handling bugs for the time being. So I think that's what I'll do. Is resource manager, like this imaginary method of saying, okay, I've loaded the mesh data, now add it to a pending queue to be processed by the engine. That process will generate an ID that can be used internal to the game, within the game engine and game code, to identify that mesh resource. And then it'll just, sometime later, before the next attempt to render, we'll get around to sending that data to the GPU. If that attempt fails, for whatever reason, we will panic with a message that's hopefully actually descriptive of the error and shut down the engine. And that should do nicely. So this is a big old stinky to do right now. This is actually not going to compile at all. Just at all. Let's close this. Let me not attempt to do this right now. Let me see what compiles and what doesn't before I start to fuck around with this too much more. God, this is gonna just be so broken. I wrote my unsafes wrong in my scheduler. Let's do, instead of pub unsafe function. Wait, is that not what it's supposed to be? Oh, did I write unsafe pub function? Oopsie. Unsafe pub needs to be replaced with pub unsafe. Place all. Let's try again. Unresolved import engine. So async resource.rs. Use engine. Async engine. Except this is evil potentially, because engine is not really going to be a thing anymore, but we'll let it do whatever it wants. We'll go one at a time. So async engine, we've got a bunch of shit that I never imported. So let's split this up and just kind of go through it one at a time. So look at this. Look how weirdly tiny these tabs get at the top when I shrink my window down. There's just like a cutoff where they get weirdly tiny. I wonder if I can configure that in Atom. Because if there's one thing that Atom's good at, it is configuration. Editor, probably not. Editor. I wonder if tabs are a plugin. If there's one thing that Atom's bad at, it's doing things in a fucking snappy manner. Atom is just slow as shit. Add new tabs at end. Add new tabs at the end of the tab bar rather than after active tab. I don't care. Color file names and tabs according to the VCS status. That's interesting. I'll turn that on for a little while. Tab scrolling, jump to the next or previous tab by scrolling the tab bar. Platform specific, I'm cool with that. Tab scrolling threshold, but no settings for making these not go all tiny when I... Can I get smaller now, or is it just like a constant cutoff? What I'm trying to find out is... Oh, they totally get smaller. I call bullshit. Okay, well, that's how it goes, I suppose. Engine, we want async engine. We've got the magic of no mem, use std mem. We need use std. I think unique is in pointer. Unique is also unstable, which makes me very sad because it is pretty useful. I believe the discussion around it is just needs an RFC to flesh out the API, which is fine. All I'm using it for is basically to send raw pointers across threads to basically tell the compiler, like, hey, this is really just the only pointer to this data that I'm sending across the thread. I want to send a pointer to this data across the thread boundaries rather than sending the actual data. What was all the discussion for it? Should it be non-zero? Should it behave like cell? But people are talking about move references. Honestly, I don't care. Whatever the Rust dev team comes up with, and especially the Rust community comes up with, I will be happy about it. I'll surely be sufficient for my purposes. I'm going to quickly slap in a few of these uses that I'm missing. Standard pointer unique. And then I'm going to quit this stream for today. We're just about done. Looks like nobody watched the entire time, which is fine by me. If nobody gets to see my horrible awkwardness, I can live with that. Standard sync barrier, and we want more than just barrier. We actually want a bunch of junk. We want arc, we want barrier. We're actually not using any mutexes, mutapodes. I need bootstrap window, use bootstrap window. What else do we have? We use std pointer. We need pointer self unique. Standard sync. Use std sync thread. I need a render and a render builder from Polygon. Use a PQRS, so use Polygon renderer builder. What else could I possibly be moving? Async init, async start workers. Source async engine. That would help if I spelled async correctly. So it's not async init, it's scheduler init. So we're gonna just do schedule, use scheduler. Actually, it's async scheduler, so this goes at the top. No windows. Render I've got now. Resource collada, load resource, source async resource. Right. Oh, you know what? You know what that one is? Well, here, let's... Okay. We got standard sync thread, no thread in sync, and no thread in sync. Is that really a thing? Where is thread? Oh, isn't just its own thing? Well, I'll be damned. I did not think it was just its own thing. So standard thread. Oh, actually making that text bigger might help people watching the stream. So I kind of did that on accident, but I'm gonna keep it that way because it's probably helpful. So what happens if I make this absolute mode? Give us a little bit more room to see stuff, right? Cool. So unresolved name async run online 68. Not the right one, is it? Macros. Oh, my macros. My macros. My macros. So my macros are how I've been getting at my async stuff, and that is going to continue to be broken. So now, so what was previously was like async whatever, oh, there's a bunch of it, is now going to be async scheduler whatever. So that should address that issue. And the next one is resource collada load resources, and that is because that is from the old engine. This stuff with collada loading needs to be moved over. Oh dear. I think anew segfaulting on me is a good sign to say today's stream is done. So with that, I will suddenly realize that I forgot to record my stream. Oh no, I didn't. I started recording. Yes. Yeah, so I think that's it for today. I will pick up with cleaning up these compiler errors and developing my newly minimalistic engine next time I stream, which will be sometime. I will see you all some other day. Thanks for watching.